Hello, my name is Joe Bierer and I'm with Bierer Associates, and today we're going to demonstrate and talk about the capabilities of our VD1000. Bierer Associates manufactures the VD1000 in accordance with ASTM standard F1796. The VD1000 is considered a Type 2 Style B voltage detector. Type 2 means that it's just a numeric with or without an audible alarm, and Style B designates that it can be used outdoors. The VD1000 has a 5-position selector switch located on the back of the meter. The first position is the off position, which is used for storage or transit. The second position is the URD position, which stands for underground residential distribution. The third position is the OH position, which stands for overhead. The fourth position is the OHT, which stands for overhead transmission. And finally, the fifth position is the test position. As the manufacturer of the VD1000, we highly recommend that the device is turned to the test position and held there until the battery voltage is displayed. You'll notice on this device the battery voltage reads 8.7 volts. This is considered good. We suggest if the reading reads 7 volts or less to go ahead and replace the battery. If the battery voltage is allowed to go as low as 6.5 volts, the VD1000 is designed to shut off and no longer function. We also highly recommend that you test the VD1000 on what's called a known voltage. A known voltage test will test 100% of the meter and determine if the meter is functioning properly or not. In this example, we are using a 3 kV power supply, which is an optional accessory for the VD1000. You'll notice the reading is reading 4.7 kV, which is a nominal voltage. We will discuss later in the video what nominal voltage means. Once you have completed the known voltage test, now the VD1000 is ready to be used. All of our underground demonstrations with the VD1000 will be done in this URD 3-phase pad mount. I've added some bullets on the left for additional information and reference. Now that we've performed the self-test and the known voltage test on the VD1000, we can begin our first demonstration. Our first demonstration will require us to take a reading within the pad mount transformer. This reading, it will require us to thread our bushing adapter into the tip of the meter probe. Notice the 1/4-20 threads from the bushing adapter that thread into the female 1/4-20 threads on the probe. Now we are ready to take our first reading. In order to achieve an accurate voltage reference in which to compare our VD1000 to, first we will use the Bierer PD25 True RMS high voltage phasing meter. The PD25 is accurate within 1%. This will give us an ability to compare a true RMS voltage reading to a nominal voltage reading. The ASTM standard F1796 does not define nominal voltage. The ASTM only delegates that authority to an ANSI standard C84.1. In the ANSI standard C84.1, nominal voltage and system voltage are synonymous. In other words, your nominal voltage is basically the same thing as your system voltage. So now, if we insert our VD1000 into the bushing of the pad mount transformer, the voltage displayed is a nominal voltage. All single probe voltage detectors can only display a nominal voltage. In order to achieve a nominal voltage reading, a voltage detector must capacitively couple to its environment. Many variables can adversely affect the reading of a voltage detector, and these would include temperature, humidity, or proximity to ground planes or other voltage potentials, high or low. If we remember the PD25, it displayed 14 kV true RMS voltage. If we compare that to the VD1000, at 15,500, we'll realize that that is accurate within 10%. This far exceeds the accuracy requirement in ASTM F1796 of plus or minus 30%. Now let's notice what happens when we insert the VD1000 into the bushing adapter closest to a ground plane. The voltage is roughly 500 volts higher. The reason why the voltage display is higher is because the VD1000 is now closer to a ground plane. Notice the distance to the top of the cabinet. Notice the distance to the right of the meter is approximately the same as the lower bushing adapter, but to the left is much closer. The large ground plane above and to the left of the meter will adversely affect the reading versus the lower bushing adapter. Notice how close proximity to my glove also adversely affects the reading. I'm a ground plane to the meter, so this will cause the reading to go higher. The distance below the meter is fine. So in this example, what is something that we can do to help improve the reading? On every voltage detector manufactured by Bierer Associates, we've inscribed what we call a physical limit mark. The physical limit mark is intended to give the user a visual indication. The indication is for two reasons. Number one, it alerts the user to not bypass the high voltage resistor located in the probe. And number two, if the user exceeds this limit into a ground plane or another voltage potential other than what's being tested, the meter may display incorrect readings. The inscription goes all the way around the probe, and we do not want to bypass the high voltage resistor to the housing. In order to gain more distance from the probe tip to the housing, Bierer manufactures what's called a 0 ohm extension. You simply thread it on to the end of the probe, and this allows a user a much greater distance from the probe tip to the housing, an additional 16 inches from the tip all the way to the housing. So let's go back to our example on the upper left bushing adapter where our reading was high. If you recall, the reading was 16.3 kV. Now the reading is 13.5 kV, or roughly 4% of the true RMS reading of 14 kV we took earlier with the PD25. Notice the distances now are much better to the top of the meter and to the side of the meter. My glove and body is still a ground plane to the meter, so it still adversely affects the display. So by installing a 0 ohm extension to the VD1000, we learned two things. Number one, by installing the 0 ohm extension, the reading is much more accurate than not having the extension on because the meter housing is much closer to a ground plane. And more importantly, you're working in a much safer environment now because the meter housing is further away from the ground plane. The probe and the 0 ohm extension working in conjunction can be viewed as a form of PPE. In other words, by achieving a much more accurate reading, you've also achieved a much more safe environment. In our underground demonstration, we had the VD1000 in the URD switch position. Now I'm standing underneath some of our overhead construction to give you reference of how high it is. This part isn't normal overhead construction. As you notice, the height is only roughly 15 to 16 feet above Earth. But because it is 16 feet above Earth, we need to now flip the VD1000 switch position to the OH position. As the URD switch position is calibrated for roughly 10 feet or lower above Earth, The OH switch position is calibrated at distances greater than that, up to roughly 40 feet above Earth. Remember, all single probe devices have to capacitively couple to Earth in order to achieve a voltage display. Since the distance I am now going to work is greater than the distance it was at the pad mount transformer, I must now internally calibrate the meter by changing the switch position to compensate for that distance. So now with the meter in the OH switch position, let's hang it on the outside phase and see what the meter reads. Hanging on the outside phase, notice the nominal voltage reading is roughly 14 kV. Now let's see what happens if we hang the VD1000 right above the neutral wire on the center phase. Notice the reading is approximately 1.5 kV higher. As we created a bad situation in our URD example by inserting the meter close to a ground plane in the upper left bushing, we have now created a similar example in an overhead application. Notice on the center phase, the meter probe is right above the neutral wire. The neutral wire is a ground plane, so now it can capacitively couple to the neutral wire, which causes the reading to be higher than the outside phase. I wanted to also demonstrate what can happen if you hang the VD1000 on a neutral wire or a ground wire down a pole. That doesn't mean there's a potential on the neutral wire. It only means that the meter is now trying to capacitively couple to the potential above it. All single probe devices will do this, so it's very important to understand that you must correctly orient the VD1000 or any other single probe device when you're working around a potential or a ground plane. So as long as the meter probe is oriented in the down position away from potential, the reading should be 0 on the display. In our last demonstration, the VD1000 is going to be used on a correct overhead build. Notice our portable training trailer to the left. That's a 40-foot trailer, so this line is roughly 40 feet above Earth. With the VD1000 in the OH position, we'll compare the reading above Earth on this demonstration versus the overhead demonstration at a lower height. I'll speed the video up a little bit so it doesn't take so long for us to get our reading. Now that we have the VD1000 hanging on the line, let's zoom in and see what the reading is. Notice the VD1000 says 13.1 kV. This is roughly 700 to 800 volts less than what it read on the lower overhead line. The reading is lower because it's further away from Earth and has a harder time to capacitively couple. We do not have any voltage potentials above 40 feet at this location. So in this video, we're unable to demonstrate the VD1000 in the OHT position. But remember, the OH in OHT does not necessarily designate the voltage potential. It actually designates the height above Earth. As an example, if transmission lines come into a substation and they're less than 40 feet above Earth, the VD1000 needs to be put in the OH position, and the reverse of that is true. If distribution lines are constructed as an underbuild on transmission towers and the lines are higher than 40 feet above Earth, the meter needs to be put in the OHT switch position. This has concluded our underground and overhead demonstrations for our VD1000. Hopefully the information we've given you today was helpful. If you have any questions or concerns about using the VD1000, you can call us at 803-786-4839. You can email us at customer_service@BieerMeters.com or email myself at joebierer@BieerMeters.com. Thank you and have a great day.